So in question 1, we are given that in each trial of a photoelectric experiment, a scientist uses a device to shine a light of single frequency on two different metals. We have three frequencies, Fa, Fb, and Fc, and we test each frequency with each metal. And then we record the de Broglie wavelength of the electrons ejected from the metal. And in part A, we need to indicate which frequency is the largest and why, and which one is the smallest. So for this, we need to note down the wavelengths of the electrons emitted. So what we know is that E is equal to hc over lambda, and therefore a large wavelength will mean a small energy. So we can also look at small wavelength. A small wavelength will mean large energy. And well, what we know in the photoelectric experiment is that we have certain frequency photon emitted incident on the metal surface, and if the photons don't have enough energy, then there will be no electrons ejected. So that's the case for Fb. So the frequency of light Fb is not high enough. It doesn't have enough energy to take electrons out from the surface of the metal. It cannot outwork the work function of the metal. Therefore, Fb will be the smallest. And then the point that we would have to mention in our paragraph is that it doesn't emit electrons. So its energy is not enough. Energy not enough. And then what we can note for comparing A and C is that Fc has the smaller wavelength electrons emitted, smaller lambda emitted. Therefore, this will have a larger energy. So this is the greatest frequency. We also know that E is equal to hf, which means that a large frequency means a large energy. And so these are the main points that we need to mention to get all 5 marks.